Okay, so number 3, calculate the number of atoms. And here you're given a mass. Okay, so we got 412 grams of neon. So this is going to require a little more thinking. We're starting with grams, and we want to end up with atoms. Do we know the relationship between grams and atoms for neon? There's two different ways to do this problem. What does the periodic table tell us? That 20.18 under neon, what does that mean? That means that 1 mole of atoms weighs 20.18 grams, right? 1 mole of neon atoms is equal to 20.18 grams of neon. How many atoms are in 1 mole? 6.022 times 10 to the 23rd, right? So that equals 6.022 times 10 to the 23rd atoms of neon. So we can go directly from grams to atoms for an element. So 412 grams times, we're going to put grams on the bottom and atoms on the top. 20.18 grams of neon is equal to 1 mole, which is Avogadro's number of atoms. So the grams cancel. This can also be done in 2 steps, and if you want to do it that way, that's fine. You can go from grams to moles, and then from moles to atoms. 412 times 6.022 EE23 divided by 20.18, and we come up with 1.23 times 10 to the 25th atoms of neon. Anybody else come up with that number? So I'll let you do the next one. I'm going to go ahead and do 4A also here. It says calculate the mass. The questions in number 4 are backwards of number 3. So here they're asking for mass, which in chemistry, if they don't tell you which unit, then assume gram. And they're giving you atoms. So atoms of iron, converting to grams of iron. Iron is Fe, and we're going to have atoms in the bottom. The periodic table tells us that 1 mole is 55.85 grams of iron. 55.85 grams of iron is 1 mole. 1 mole is Avogadro's number. So down here again we have the 6.022 times 10 to the 23rd atoms. Yeah, it's just switched. In 3, we were going from grams to atoms. In 4, we're going from atoms to grams. And so could you do these by just looking at the pattern? Yes, you could. But you won't have a pattern to look at on the exam. So you need to understand how we're doing this. 8.51 EE29 times 55.85 divided by 6.022 EE23. And that's the answer I came up with is not correct. I came up with a huge number. I did something wrong. Well, that's still a big number, but it's not as big as... I was getting something to the 29th power. That was way, way too big. So I'm coming up with 7.89 times 10 to the 7 grams. Anybody else?
Number 4, 89 times 10 to the 50. Oh, I got that.
10 to the 53? You have a calculator error then. Anybody else get 10 to the 7?
Yes.
Yes, okay. If you're coming up with 10 to the 53, then you're not entering scientific notation correctly. So make sure you do 6.022 EE23.
This is grams, right?
Grams, yeah. Which that sounds like a crazy huge number, and yet that's in the range of tons. So it's a big number, but it's not impossible.